Hi everybody, this is Mr. Nolan, and what I would like to do with you today is talk to you about one of the mysteries that we observed in Michigan's bedrock. So when you're walking around outside, especially in Michigan or in the north or northeast, you're generally walking around on soil, sediment that has been deposited there as a result of erosion and transportation, and then later on deposition. We have seen that glaciers played a significant role in the surface features of Michigan. But the real mystery that we noticed in some previous work that we did is that the bedrock of Michigan has a very conspicuous feature that you can see on your screen, and that is that it forms these really remarkable ring structures, especially in the lower peninsula, and you can even see evidence of a piece of the ring structure up here and in the upper peninsula. We're going to focus on the lower peninsula today, but it's very, I would call it conspicuous. It sticks out. It's very easy to spot. We have this rock in the middle, and it's surrounded by other layers of rock, and it's rings, right? We would call that rings, or maybe circles, circular structures. What we want to be able to do in this video, the goal here, is to be able to use these bedrock features to identify if this structure is created by what's called a basin or a dome. And so that's what we want to be able to do today when you walk out of here, is be able to figure out, are these ring structures created by a basin or a dome? Those are really the options that we have here. So let me show you what I'm talking about. We can actually model these with clay. And so I want to show you what each of these looks like, and I'll show you what we're going to do to figure out, is this ring structure in Michigan a basin or a dome? So I'm going to blow up the screen here. And so what we can do here is use some Play-Doh to create some models of basins and domes. Now if you look here at what these sort of look like, I'll hold them right up to the camera here. These are some structures that we can make that are evidence of basins and domes. This one on this side over here that I'm kind of wiggling, this we would call a basin, and you can see it's almost shaped like a bowl. Now the surface isn't actually bowl shaped, it's just that the layers kind of are. And if we look really carefully at this basin, we can see that red is the very lowest layer of bedrock. Yellow comes next, and then at the very top there's a little bit of brown. And while you're looking at this basin, I want you to think about which layers are older and which are younger. Are the deep layers, these red ones, older, or is it the ones that are shallower? Well, if you think about it, when layers are being formed, they're going to be, formed maybe in like an ancient ocean or some sort of aquatic environment. And then as those sediments are built up, they're being added on top of the ones underneath them. So if we're looking at our basin here, these red ones are really the oldest sediments, right? They're the deepest, and so they are therefore the oldest ones. These brown ones on the surface here, toward the middle, these ones are quite a bit younger. So we've got old red ones down here, and then we have some younger brown ones. And over here for our dome, it's totally the opposite. Now notice that the order of the layers is actually the same. We have the brown stuff that's sort of on the top here, and then under that we have some yellow, and then way down kind of at the very bottom we have the red. Right? You can kind of see that red there. So these are actually, even though the shape is sort of flipped upside down, the layers are arranged in exactly the same order. On the very top, the youngest stuff, we have brown, and then the oldest stuff is the red at the very, very bottom. And that's called the law of superposition. We'll look more at that in future lessons, or maybe if you've taken Earth 1, you might have gotten those lessons already. But I want to show you what we can do with these. After the structure has been created in deposition, we have other processes that can take place. If these are now exposed to the air and the elements, wind and rain and glaciers and things, they can be eroded. And so what we're going to do is, now that we've created our dome over here and then our basin over here, we're going to erode them. This is just some modeling clay that I whipped up and put some dye in, but we're going to take a look at what happens here when these are eroded. Now, I'm going to use what's called a sanding block to erode these structures, and I'm going to show you what patterns emerge in these structures when I sand them down and erode them. So I'm going to start with the dome. So here's our dome. We've got the brown on top, and we've got the yellow and then the red. I'm going to start eroding, and then I'm actually going to fast forward through the video, and I'll show you what this ends up looking like. So all that this means, really, if I'm using the sanding block, I'm just going to take my dome. This is the part that's on the top. This top is what's going to get exposed to the elements and erode it. So I'm just going to use my sanding block, and I'm just going to go ahead and erode the heck out of the top of this dome, because this represents the surface of my landscape that's now getting eroded. So I'm going to go ahead and erode the heck out of this. I'll pause the video and I'll show you what that looks like after I've eroded it. And then we'll do the same thing with the basin. Okay. So I've gone ahead and I've eroded the top of my dome off. So this kind of represents the actual surface now that you maybe would walk on if this had now been eroded. And I want to show you what that surface looks like. So if we kind of tip it over and look at the top, I know the colors aren't amazing, but if we look really carefully here, you see how the brown, which is the younger layer, is over here on the outermost areas of this dome. And then as we go toward the middle, the red, which is deeper and older, is actually peeking out through the middle. So remember how that red with our dome was at the very bottom? It's the oldest stuff. Well, over here, when I go ahead and I erode the top away, we can see that the older material is peeking through the middle, and then the younger material is up here around the sides, this brownish stuff. So let's go ahead and do the same thing with the basin, and this one over here, and we're going to see what pattern emerges when we erode the heck out of that. So again, I'm going to fast forward a little bit, and then we'll see what happens when we erode this basin. Okay. So let's look and see what our basin did when we eroded it down. So if we look really closely here, this is the surface. So we're looking at it like this. This is our basin. If we look at the surface where we eroded it, we can see that those younger layers, the brown is right there in the middle. It's surrounded by the yellow, which was in between. And this one actually has the pink color, the oldest stuff, that's toward the outside of the ring. If you look really closely, that's actually on the outside, which is the opposite of our dome. So this one was our dome. Remember, the oldest rock layers, the pink stuff showed through the middle, whereas over here, for our basin, the oldest stuff is on the outside. And so something that's very important to note here, the order of the rock layers is the same. We have red on the bottom, followed by yellow, followed by brown, which is the youngest. It's just the shape of the structure that has changed the way that that looks on the surface. So if I create a dome, if I have a dome that's going to get eroded away by the when the bedrock is eroded, I end up with the oldest materials toward the middle. The oldest rock is toward the middle. If I have a basin, then the youngest rock is toward the middle. This brown stuff that's actually kind of sitting on the top is in the middle. So this is how we can tell whether a structure that we're looking at is a basin or a dome. We look at the relative ages. We look at how the ages compare in that structure. So what I'd really like to do is to go ahead and direct your attention again at this little model of Michigan and then remind you how the ages are arranged in our state. These sort of orangish rocks right in the middle, these are the youngest bedrocks in the state. They're Jurassic. Now you might be thinking, oh, the Jurassic, times was forever ago. They were a long time ago, but these are actually the youngest rocks, bedrocks that we have beneath all the sediment. As we move out away from the center of the lower peninsula, they get older and older. So we have, Devonian, Pennsylvanian, and Mississippian, and Devonian, and Silurian, and Ordovician, and then eventually at the very edges of the dome, we run into Cambrian rocks, which are very old. And so the idea here is simply that we have young rocks in the middle, and then we have very old rocks toward the outside. And I want you to think about which of these does that resemble. I know my screen is really tiny, but is the basin, this one here, where we have young rock in the middle and old rock toward the outside, is that more like Michigan's shape, or is this more like it with the old material in the middle and then the younger stuff toward the outside? Which one is that? Do you remember how these are arranged? If you remember that the basin has the youngest stuff in the middle and the older stuff on the outside, then it should make sense that Michigan structure is actually formed by a basin. It's called the Michigan Basin. And so these Jurassic rocks sitting in the middle are young, and then these ones over here, these Cambrian and Ordovician Silurian rocks, are old and very, very deep. And so I want to show you one more way to sort of visualize this. It's a computer program that I found that I think is really interesting. I want to show that to you and make sure that you understand what these structures look like, both from the top and bottom and the sides. That way we can really sort of visualize these structures. Okay, so I want to show you this program. This is a website called Visible Geology. And what I have done here, previous to this video, is I created a three-dimensional model with layers. And remember, the deepest layers are the oldest, and then the upper layers are younger. And what this program allows me to do is to create domes and basins and see what they do to the surface. So the blue one is on the surface right now. If you look on your screen, the blue one is on the surface. So I'm going to go ahead and create some domes and basins and see what that does to the surface. So here for this program, I'm just going to select dome. Let's start with the dome. And I'm just going to click Add New Dome or Basin Event. And so I'm going to click that a few times. And notice what the rock layers are doing. The rock layers are bending up, right? I am creating a dome. I'm bending these rock layers up. And so I'm bending it, I'm creating this dome. And let's go ahead and take a look and see what the surface does when I do that. So here I can see that I've got these circles. So the youngest rock, that blue stuff, is toward the edges, and as I go deeper down, the older stuff shows up in the middle. You see that? I can keep adding more, I can keep pushing up on that dome, and I can see that more and more of those old materials are becoming exposed. And they sort of are growing in size as that dome grows. And so here in this particular model, we can see my very deepest, my very oldest rock is now peeking through the top, through the middle. And so this, if I just remember, if you ever find old material in the middle and then it gets younger as you go out, that's a dome. And the reason is this is what the bottom looks like, or the side, right? The oldest materials are peeking up through the middle. So this is not what Michigan it causes Michigan's ring shapes. Now, using this particular program to illustrate a basin is a little bit too difficult. But the important thing to walk away from this program to recognize is that if you have a dome, it's older in the middle, it's younger toward the edges. But because we see that's actually the opposite of what we see with Michigan, it's younger in the middle and older on the edges, that means that Michigan is actually the result of a basin, right, like the one that we created and eroded right here. So I hope that this was helpful in being able to sort of look at these three-dimensional shapes, structures, and be able to use them to, at least as a model, to be able to explain why do we see ring structures in the state of Michigan, and why do we see that their ages change from youngest in the middle to oldest as we move out. So at this point, you should be able to use bedrock features to identify if a geological feature is created by a basin or a dome.